Hello, everyone. My name is Karishma Punwani, and I'm the Director of Academic Product Management here at Maplesoft. A big thank you for all of you for coming to this sneak peek webinar. It's my pleasure to be able to show you some of the highlights of Maple 2026. So Maple 2026, it combines a number of enhancements to our core functionality with thoughtful integration of AI, and you'll see that in just a moment. It also includes a number of benefits for members of the Elite Maintenance Program. So without further ado, let's get started. So one of the features I'm most excited about in Maple 2026 is the AI Assistant. So let's start here. The AI Assistant was developed to really help users, both new and seasoned, accomplish tasks in Maple as fast as possible. Think of it as a personal assistant. The AI Assistant is located, let me open the panel over here, right over here, and you can interact with the AI Assistant using natural language. You can ask it questions like, create a polar plot or explain differential equations to me, whatever it may be. The AI Assistant will provide you with text, mathematics, code, all of this which you can import into a Maple worksheet. So I'm really excited about this. I have 3 videos that I'm going to show you that highlights different features of the AI Assistant. So let me get started. And one thing I should mention, let me pop up this video over here, is that with the AI Assistant, the math is done by the Maple Math Engine. We're not offloading the mathematics to the AI. We're just using the AI Assistant to allow people to achieve the results that they want. So let me play this video. Let me make it bigger. So you'll see in this particular video, what I'm doing over here is I'm selecting the section. And what I have is a hand-drawn image. And I'm saying refer to the selected selection. I want to recreate this hand-drawn image. So I'm telling the AI what I want it to do in natural language. I'm saying I want a 2D plot of unit vectors radiating from the center of a circle. And then I go on to say the vectors are evenly spaced around the circle. So I type it in, press enter, and voila. I get a bit of an explanation. It's telling me it's going to use plot tool circle and plot tools arrow, and it gives me code. I can then insert the entire conversation or the code snippet directly into Maple and press enter, and it executes. And if I want to make changes, this is not quite what I wanted, I can go ahead and modify the code. Now it's in my worksheet. I love that the AI Assistant comments the code, so it's easy to modify. But if it wasn't, if you had difficulties, you could just go back to the AI Assistant and ask it to update the code for you. So that's the first example that I wanted to show you. Second example is creating a worksheet. Sometimes I find the hardest part is just getting started. You have to build a worksheet, whether it's a lesson, whether it's some notes. And what the AI Assistant does is it expedites that process. So over here, what I've done over here is I'm asking the AI Assistant, I'm saying I'm a teacher, create a worksheet to help me explain Newton method to my students, take advantage of features in Maple to generate a plot and an animation. And so it goes ahead, and taking a worksheet takes a little bit longer, but we're talking minutes over here. And you'll see momentarily it will give me a response. Again, what you'll get is worksheet fragments, you'll get code, text, math is formatted in 2D math. All of it is there ready for me, and I can insert this entire conversation into a new document. You can see it here. I can execute this worksheet, and you'll see I get the plot as requested. So here, and it's using Maple's Newton methods command, and I get an animation as well. So that's the next example. And if this worksheet, let's go back here. If the worksheet wasn't exactly formatted or it didn't include everything that you were hoping to do, go back to the AI Assistant, ask it to make modifications for you, or now you have this as a starting point, feel free to make the modifications yourself. Take advantage of all of the documentation tools that are available in Maple. You could add images, you could add highlights to any of the math, do things, because Maple is a technical document environment, so you can leverage that to create your worksheets. let me show you another example. So all of us, myself included, have run into situations where we've done something in Maple and we get an error. So in this case, I'm using DE tools. I'm trying to create a direction field plot. So you see I've executed this, I get this error, and now I'm asking the AI assistant. It's very simple. What am I doing wrong? I don't need to be eloquent. Why does this command not generate a direction field plot? And so I'm asking the question and I'm providing it with the error message that I got. I could have easily highlighted this entire section and said, what am I doing wrong? Refer to this section. In this particular example, I wanted to show you copying and pasting math into the AI chat area. So again, it'll think, and then it will provide me, as you'll see over here, an explanation of the mistake I made. In this case, I forgot to supply the dependent variable. Perfect. It will also give me a code snippet. So I can insert this code snippet into my worksheet, and as you'll see momentarily, I will get my direction field plot. It also provided me with a second code snippet. It said, if you want the arrows colored by the slope, you can also do, and it proceeded to give me code. This code, unfortunately, generated an error, as you can see. But that's fine. The AI is not perfect. It does make mistakes, but I can just copy and paste this error message directly into the chat and ask the AI assistant to fix it. Again, I don't need to be eloquent in how I ask. I can just copy, paste, and say, please fix. And the AI will go and make its best attempt to fix this and give me better code. So I can do that as well. It'll fix it, and in a moment, here's the new code. I'll insert it into my worksheet. In fact, it gave me 2 procedures, and I can go ahead and insert that directly into my worksheet. I'm showing you both of the different procedures right now. And here we go. I insert this, and I should get the direction field plot with colored arrows based on slope. So that was the third example. So I encourage you to try out the AI assistant. I'm really excited about how it can help new users and existing users be more productive in Maple. And rest assured, the math is done by Maple, not the AI assistant, or not the AI. So another way we're leveraging AI technology is document import. I can't tell you the number of times I've had a customer tell me, I want to do something in Maple, but all my notes, my lecture notes, my PowerPoint, my journal article, they're all in different formats, none of which are in Maple. And it's a struggle. And so sometimes that causes a barrier for people getting started in Maple. So what we've done in Maple 2026 is we're using AI to help people bring material into Maple. It could be journal articles, lecture notes, PDFs, whatever it is. Bring it into Maple, including text, math, images. And so here you have all different types of formats are supported: PDF, documents, as well as PowerPoints. Let me show you how it works. So I give 3 examples again. Here are some handwritten notes. I'll pop it up on my screen over here. These were handwritten notes from my colleague that my colleague took when he was a student in his Calculus 3 class. You'll see them over here. These are 5 pages worth of notes, handwritten. There's some sketches, cursive writing. There's a shadow over here. Doesn't matter. I'm going to go, let me put this up here so you can see a little bit better. Oops. That did not snap the way I intended. Let's try this again, because window snapping, it should. There we go. That's what I wanted. Perfect. Okay, so these are side by side, and now I'm going to go to File, Import, select a document, and I'm going to pick my math notes. And all I did here for this, to get this particular PDF, I literally took pictures of my colleagues' notes, and I just put them or saved them as a PDF. It's as simple as that. I could have also taken the pictures, put them into a Word document. Here I have it in a matter of seconds. I have a document that mimics what I have on the page. So here, the definition of limit. You see there's a little sketch here. I have the sketch over here. The math, it's all executable. It's all formatted in 2D math. Occasionally, it might make a few mistakes in terms of if it couldn't understand my colleague's writing. You can easily fix that. Now it's in Maple, and that's the part that excites me most. You know, this would have taken maybe an hour or so in order to bring it all into Maple. And now I have it within seconds and I can make changes to it. You'll see over here, this is that image that was from my colleague's notes. And once it's in Maple, now you can start using the Explore command. You can create a visualization. You can write a procedure. You can do all of these things leveraging Maple. So that's the first example. Next example I want to show you is PowerPoint. So here I have a PowerPoint presentation. I'll just open that up. I'll show it to you. PowerPoint presentation has 12 slides over here, has some text, has math, has images, as you can see, more math. And I'm going to take this and import it directly into Maple. So again, File, Import, select the document. I'm going to select my PowerPoint. Open that up, import. Now, if I wanted to, I could import multiple files at the same time, and I can even output those to files. So basically, it'll do the conversion and output everything in as MW files and save it to a particular directory. So again, high fidelity. So in this case, this is the title. Each slide gets its own section. So bullet points. Here again, the math is live. I get this image. This is the same image I had over here. And you can just see it. These are more of the same. The images came in. Oops. And I can keep scrolling down. So this is the next one I wanted to show you. And the last is a journal publication. So here's a PDF of a journal publication, lots of text, lots of math, using symbols over here. And I have 23 pages. I'm going to bring that in with a single click. Here's my publication, open, import. And within seconds, I should get this 23-page journal publication in Maple ready for me to do whatever I want. If I wanted to verify a calculation, I can do that. If I want to create a plot, I can do that. The key is that it got it into Maple. So here it is. You have some of the details, and I can look at it. All the symbols are represented. I can see everything. This is section 3 is over here. And it all came in. Again, the math is executable. So that's another one of those AI-powered features that I'm really excited about in Maple 2026. So let's make this full screen again, and I want to talk about companion products. Earlier, I mentioned a number of benefits to members of the Elite Maintenance Program. And so I wanted to just take a moment to explain what some of those benefits are. So of course, EMP members get access to the AI-powered features that I showed you momentarily, or a moment ago, I should say, access to Maple Calculator Premium. So over here, if you have membership to the Elite Maintenance Program, which you do once you purchase Maple 2026, you will then get Maple Calculator Premium. And to establish the connection to get it, all you'll have to do is, here's a page, scan a QR code, and then just from inside Maple, sign into your Maplesoft account. It's as simple as that. Then go to the Maple Calculator, sign in with the same credentials, and you'll have access to Premium. You'll also get access to Maple Learn, full access to Maple Learn. One of the nice things about Maple Learn is that as a Maple user, you can create content, and using the Document Tools Canvas package, you can deploy that content to Maple Learn, which is our web-based tool for teaching and learning mathematics. And then you get access to our Maple MCP. MCP stands for Model Context Protocol. What this does is it gives you the ability to power your favorite external AI tool, say ChatGPT, with the Maple Math Engine. And so if I go to this My Maple ribbon, which is new, click on Maple MCP, you'll see over here I have an access code. If I click on this, I'll get setup instructions, and I can take this and set my instance of ChatGPT up so that when I'm performing or want to do computation, ChatGPT can offload those computations to the Maple Math Engine. So that's another benefit of Maple 2026. Something else I wanted to talk about now, moving on to math, is the improvements that we did to linear recurrence equations. I'm really excited about this. So Maple 2026 expands our ability to solve linear recurrence relations. And one thing I want to say over here is Maple can now fully solve 94% of the over 55,000 plus entries in the OEIS, the Online Encyclopedia of Integer Sequences, that can be shown to satisfy a linear recurrence relation. Maple can do almost all of them. And so this comes about due to significant effort, research in this particular area. And it's something that I'm very proud of. We have major extensions to the LRE tools package and substantial enhancements to RSolve. And so in short, Maple now solves broad new classes of homogeneous and inhomogeneous recurrences, including many second and third and fourth order cases that were previously beyond reach. Something else that I want to say is that while some systems can solve isolated third or fourth order cases, Maple is the only one that provides systematic coverage of higher order recurrences at a level not available anywhere else. So it's something I'm very proud of. Now, as I'm looking at these examples, I realized that maybe I should have started off and, explained what a linear recurrence equation is. So for those of you who might not be familiar, a linear recurrence equation is one where the nth term of a sequence of numbers is equal to some combination of the previous terms. A famous example of a recurrence is Fibonacci numbers. And what is the OEIS? It's a widely used research database of integer sequences. And so it has thousands and thousands of integer sequences, and this is the one where we've been using to test and ensure that we can solve these recurrences, or the linear of recurrences, that is. So I have two examples over here. Why don't I go ahead, and I'm just going to remove the output from the worksheet, and let me show you this first example. So this first example, simple recurrence, but previously could not be solved by RSolve. And in Maple 2026, we can. So you'll see it over here. Now the solution is given in terms of the Bessel function, and I can go ahead and confirm for at least small values of n that this is in agreement with the recurrence. Here's the second example. So this is a third order recurrence, and it could not be previously solved by RSolve. It comes from the OEIS. All I did was I took this and I copy and pasted it here. And what I did now is I'm going to use the LRE tools guess recurrence. It's a command. I'm going to use RSolve. And you'll see again, I'm going to evaluate the solution at small values of n to confirm agreement. So here it is. And there we have it. So this is an area that I'm very excited with. Linear recurrence equations can be found in combinatorics, number theory, special functions, and applied mathematics. And continuing on with math and advances in our math engine, there's a number of different things that we did over here. Again, let me remove this from the worksheet. So the list is long, and you can see it over here. And I will not be able to cover everything in this webinar, so let me show you a few highlights. So we have improvements to assumption handling and logic inference. So the assume facility including the command, I should say, assume for declaring assumptions, and the commands is and could it be for reasoning under those particular assumptions. They form a core part of Maple's symbolic reasoning engine. And in Maple 2026, we've improved them substantially for robustness, correctness, and the scope of reasoning under assumptions. So I'm going to give you a few examples over here. In this particular case, 2 examples. Maple 2026 improves logical inference in a variety of common and not so common cases. So here it says that this is true, false. It is able to simplifies this expression 2 minus 2, and it recognizes that that is an integer in this case. So this is now here. We have improved interpretation of assumptions. I'll show this to you. We have improved logical consistency. So in previous releases, these would return false when in fact they should have returned fail. And we have amended that in Maple 2026. We have improved robustness and special function handling. There's enhancements to simplify, as you can see over here. So simplify has long performed the conversions or these conversions. And in 2025, we applied similar transformations to hyperbolic functions. In Maple 2026, we've taken it a step further, and simplify now performs the reverse transformation. And you can see that over here. There's improvements to logarithmic simplification, improvements to combine, to eval-c, to differential equation solving. All of this is here. There's improvements in sum tools, fsolve. There's lots over here. And I think I would encourage you, depending on your area of interest, to take time with these help pages. They go into a lot more detail. And you can really see all the things that we've done to the Maple Math engine. Plotting themes. Now, Maple has a number of different options. Let me remove this. So Maple, like I said, has a number of different plotting options, but sometimes you had to use many of those options in order to get or meet a certain visual criteria. So it required setting or multiple settings, I should say. So in Maple 2026, we have this a theme command. And so the theme command, what it allows you to do is to create a custom theme that you can apply to all of your different plots, which gives you the same visual consistency, the same visual look. And it allows you more easily to maintain that visual consistency in worksheets, your teaching materials, reports, so on and so forth. So in Maple 2026, we have a number of canned themes. You can query that canned theme. So if you like one, you can query it and then make modifications. And of course, then you can create your own custom theme. So one of the themes is called Gray Grid. So as I was saying, one of the themes is called Gray Grid. And so here you have it. This is for sin x, cos x, and tan x. And here's my theme. For my data set over here. Now I have experimental data. So notice over here, plot changes size, plot thickness is changed. So here I get a point plot, spreadsheet points. This is another one. Grayscale, everything is gray. Spreadsheet lines. Dark gray grid. I already showed you gray grid, but it's here, so I'll show it to you again. And then reverse. So these are all the canned themes. Again, feel free to query them, make your adjust them and make your own themes. And how do you make your own themes? Well, here's an example. So in this example, I have 2 supplied lists that correspond to my 2D and 3D plots respectively. So I've created my theme. I've called it my theme. I've given it colors, the shading for the 3D. I've defined the size of the plot. And now I just apply the theme. In this next example, I'm going to apply a custom theme to a contour plot. And here we have it. So in this case, I said, I don't want a color bar. I want the size to be this. I want it to be filled. The color should be black, so on and so forth. Education. This is an area that is really close to my heart. Let me remove the output for the worksheet. And we have, over the years, made a number of improvements when it comes to education. And we've done it again in Maple 2026. So there are 3 features that I'm really proud of in Maple when it comes to helping students develop an understanding for mathematics. Check My Work, which provides students with guided feedback. Try Another, which allows them to generate a practice problem that is similar to the one they were practicing, and step-by-step solutions. And in Maple 2026, we've made improvements to all 3 of these. So in Check My Work, the 2 things that I wanted to talk about is the improved handling of implicit assumptions. So sometimes students have, or I should say, sometimes steps have implied context. And for instance, a student is using rules that are only valid under certain domains. What happens is the student may not always explicitly state their assumption, but the analyzer will take this into account, allowing these transformations without requiring the student to make the assumption. So in this case, for example, that x is greater than 0, be stated explicitly when manipulating ln of x. So you'll see over here, it is saying, okay, assuming positive. Another improvement is, let me run this example over here. Sometimes the analyzer doesn't have all the information that is needed for a particular problem. So for example, in this example, the coordinates over here that are shown on the graph, but they're not actually mentioned in the problem. But that's okay. What happens in Maple 2026 is the feedback algorithm now sees the assignment of values to variables and allows them, as long as they don't contradict any previous or subsequent use of those variables. Another improvement that I wanted to share when it comes to generating practice problems. Try Another. In previous versions of Maple, we took our first step towards solving this, the ability for a student to find a good practice problem. And it generates a new random expression with properties similar to the given one. In Maple 2026, we've expanded this capability to include many more kinds of expressions and improve the controls over coefficient scaling, especially when repeatedly generating new expressions based on the previously generated one. Again, let me show you some examples. So here, notice I'm asking it to generate similar. All the coefficients are fairly similar. And so this is something that we've made significant strides to do in Maple 2026. In this particular example over here, it's in vertex form and it has integer roots, so you would expect the similar problem to have the same features, and it does. Here, this polynomial has common factors, and the new one should have common factors as well. Again, another example. You have a cubic equation that contains a sum of, or difference of cubes, and it should produce another cubic equation with sum or difference of cubes, as you can see here. So that's another area that we've improved, and step-by-step solutions. So Maple's computational algorithms are optimized for speed, breadth, and efficiency. And the step-by-step commands, well, they are designed to mirror how a student might approach a problem. And because the approaches serve different purposes, the results returned by the computational command and the step-by-step solver, they're not always mathematically equivalent. So in Maple 2026, what we did is to reduce that confusion. We have strengthened the internal use of simplified steps, so it'll bridge to the expected final result when possible. And this helps ensure that the step-by-step solution and the computational result agree. So here we have it over here. So here you start off with this expression, and it's going ahead and it's doing this. And then you're seeing that it's going to now continue. So simplify steps kicks in order to provide the student with a result that they would see if they had used the computational algorithm. Here's another example. Same thing. And the last one. More improvements. In terms of programming, we have improvements, a number of different improvements. I'll remove the output, and I want to focus for today just on the improvements to vector database. So before we look at this example, I want to take a moment to briefly explain what a vector database is, especially for anybody in attendance who may not work with these ideas regularly. So you can think of it a bit like a recommendation system, Netflix or Spotify, how they work. You have these movies and songs, and they can be represented by, a long list, thousands of different features, characteristics. Think of things like genre, pacing, or move. So you have these movies or songs that are represented by these thousands of features or characteristics, and that list of numbers is called a vector. And so when you watch something, the system looks for other items whose vectors are closest to the one that you're currently looking at. Those are the items that are most similar, so they get recommended. And the same idea shows up in many areas today, so including machine learning, data analysis, and modern AI systems. And the core task is similarity search. Given one vector, find another vector in a large collection that are most similar. So let's walk through this example. So we're going to load the vector search package. I'm going to create a database over here, and I'm going to create it so it has vectors of dimension 1500. I'm going to have 1,000 random vectors. I'm going to add those to it. So here it is. I'm going to add it to my database. That takes a moment. Now I'm going to construct a vector that is near to some 20 of these vectors. And I'm going to say, find 30 of the closest vectors. And it did it. And then what's the distance between these vectors and V? And here it is. And then, of course, I can go and save this vector database to a file. When it comes to performance, again, a number of different improvements. Let me scroll so you can see. One of the things I wanted to talk about is the improvements when it comes to calculations involving quantities with units. This is something that has been requested by our professional users over the years. And so it's an area that we have made progress in. So in this example right now over here, it takes on my colleague's machine 0.028 seconds in Maple 2026 compared to 2.5 seconds in Maple 2025. So let's see how it performs on my machine. And super fast over here. Here's another example again. This in Maple 2026 on my colleague's machine completes the loop in 0.192 seconds. And when you have unit simple loaded in Maple 2025, it took 0.462 seconds. And you can see just how fast this is in Maple 2025, or Maple 2026, I should say. And the last thing that I wanted to talk about is the improvements that we've made to ensure that our users get up-to-date fixes and improvements that we make to the Maple library. So this is something that we introduced in Maple 2025, but the process for getting these updates was maybe a little cumbersome. And so we've improved that in Maple 2026. All you need to do is go to support tools, /update from within Maple, and it'll automatically download the latest update from the Maple cloud and install it into your local libraries. So that is an improvement. You don't have to wait for a point release or the next major release to get library improvements. We are delivering it to users through this support tools package. So lots of things in Maple 2026. I am super proud of it. A lot of hard work went into this release. I think once it's out, many users will enjoy it. Feel free to evaluate it. If you have any questions, don't hesitate to contact us. Once again, thank you for taking the time to attend this webinar. My name is Karishma Punwani, and I'm the Director of Academic Product Management here at Maplesoft. Have a wonderful day.